Morning everyone. On behalf of my team, I would like to welcome you all. Our topic is satellite design consideration. Myself Aditi Verma and this is our team. This is what lined up next. So let's start with the introduction. So designing of a satellite begin with a baseline spacecraft design meeting all the requirement such as EIRP and coverage as shown in the figure. Let us consider some major design consideration of a satellite. So, a satellite consists of the spacecraft bus, which is primary spacecraft structure containing power, temperature control, and the most important is communication payload, which receives, amplify, and transmit the signal. Satellite contain multiple channels called transponder that provide bandwidth and power. So, satellite should be designed by keeping in mind its usability and short and long-term effect throughout its lifetime. Parameter for design consideration. So here we can see that two critical consideration in designing are power and coverage, such as some satellite can cover a huge ranges of 33% of Earth's surface and some have limited resources and transmitting quality may also differ. So satellites are designed by considering different ranges. For C-band ranges up to 4 and 6 GHz. For Ku band it may be ranges from 11 and 14 GHz. For Ka band it ranges from 19 and 24 GHz. Commercial satellites are grouped into three categories such as FSS, MSS and BSS. FSS is fixed satellite service. This uses ground equipment. It supports the majority of our domestic and international services. Second is mobile satellite services MSS. It uses a variety of transportable receivers and transmitter to provide communication services such as mobile services, land services, etc. Coming to next, broadcast satellite services. This offer high transmission for reception. It is known for its direct to consumer television such as direct TV.
Payload. In case of satellite, the payload is a communication antennas, receivers and transmitter. The rest of the unit is to provide structure, power, commanding and telemetry services. Payload is like the warhead of satellite. So the satellite is designed considering that it can withstand any condition and support the payload till it reaches its destination. Design structure of a satellite constitutes of satellite, transmitting and receiving earth stations. So while designing, factors like transmitting power, antenna gains, also various types of losses such as atmospheric losses, polarization losses and free space losses all needed to be considered so to get the successful transmission after the launch of satellite. So after considering all the losses, the power balance equations come out to be as shown in the PPT, which is PR is equal to PT minus LT plus GT minus LP minus A plus GR minus LR. This helps significantly in the design of satellite power handling capabilities. The same equation can be written considering uplink and downlink parameters as follows.
Antenna. An antenna is a metallic structure that captures or transmits electromagnetic waves. Antenna works by catching incoming signal at a certain frequency and reflecting their shape in other direction. Four main types of antenna are used on present communication satellites are firstly wire antennas, horn antennas, reflector antennas and array antennas. An antenna array is a group of antennas connected and arranged in a regular structure to form a single antenna that is able to produce radiation patterns and not produced by individual antennas. Types of antenna in a satellite design. Pyramidal horn. A pyramidal horn is a horn antenna with the horn in the shape of a four-sided pyramid with a rectangular cross-section. Conical horn. It is made by flaring out one end of circular waveguide. Corrugated horn. The corrugated horn antenna has parallel slots or grooves along the inside surface of the horn and transfers to the axis. Multi-fur horn. It has low side lobes and feed for reflector antennas. Nextly, center field parabolic antenna. It has high field line loss and aperture blockage for side lobe and gain reduction. Offset parabolic antenna. An offset dish antenna or off-axis dish antenna is a type of parabolic antenna. Cascade antenna. A cascade antenna is a parabolic antenna in which the feedback antenna is mounted at or behind the surface of a concave main parabolic reflector dish, and it is aimed at a smaller convex secondary reflector suspended in front of the primary reflector. Offset cascade antenna. The reflector can be analyzed using the version of graphs available from the TICRA using a Gaussian beam feed antenna.
The Earth station of satellite communication system mainly consists of two Earth stations. Those are transmitting Earth station and receiving Earth station. The transmitting Earth station transmit information signal to satellite, whereas receiving Earth station receive the information signal from satellite. Sometimes same Earth station can be used for both transmitting and receiving purpose. In general, Earth station receive the baseband signal in one of following form: voice signal and video signal, either in analog form or digital form. Block diagram of Earth station. Designing the Earth station depends not only the location of Earth station but also on some other factor. The location of Earth station could be on land, on ship in sea, and on aircraft. The depending factors are type of service providing, frequency band, utilization, transmitter, receiver, and antenna characteristic. The block diagram of digital Earth station shows below. There are four major subsystems that are present in Earth station. Those are transmitter, receiver, antenna, and tracking subsystem. Transmitter. The binary information enter at base station, equipment of Earth station from terrestrial network. Encoder include error correction bits in order to minimize the bit error. In satellite communication, the intermediate frequency can be chosen as 70 MHz by using transmitter having bandwidth of 36 MHz. Similarly, if intermediate frequency can also be chosen as 140 MHz by using transmitter having bandwidth of either 54 MHz or 72 MHz. Up converter performs the frequency conversion of modulated signal to higher frequency. This signal will be amplified by using high power amplifier. The Earth station antenna transmit this signal. During reception, the Earth station antenna receives downlink signal. This is low-level modulation RF signal. In general, received signal will be having less signal strength. So, in order to amplify this signal, low noise amplifier is used. Due to this, there is improvement in signal to noise ratio value. RF signal can be down converted to intermediate frequency value, which is either 70 or 140 MHz, because it is easy to demodulate at this intermediate frequency. The function of decoder is just opposite to the that encoder. So the decoder produces an error frequency free binary information by removing error correction bits and correcting the bit position if any. Earth station antenna. The major part of Earth station antenna are feed system and antenna reflector. These are two parts combined together radiate and receive electromagnetic waves. Since the feed system obey reciprocity theorem. Tracking subsystem. The tracking subsystem keeps track with the satellite and makes sure that beam comes towards it is in order to establish the communication. The tracking subsystem present in Earth station perform mainly two functions. Those are satellite acquisition and tracking of satellite. This tracking can be done in one of the following ways. Those are automatic tracking, manual tracking, and program tracking. Equivalent isotropic radiated power (ERP) is the total radiated power from a transmitter antenna times the numerical directivity of antenna in the direction of receive. The effective radiated power from the transmitting side and is the product of the antenna gain and transmitting power, where ERP is GT plus PT minus LF, where LF is feed losses. Signal power is given by ERP minus path loss plus GR, G by T ratio. The antenna gain to noise temperature ratio is figured of merit to indicate the performance of Earth station antenna, and low noise amplifier relation into sensitivity in receiving downlink carrier from the satellite. The parameter G is receiving antenna gain referred to input of the low noise amplifier. Here we explain one example where we got C by N is 13.11.
Applications of a satellite. First, weather forecasting satellite. Weather satellite are an important observation tool for all scales forecasting operations, such as satellite data having a global view complements land-based system, as you can see in the figure, such as radio sondes, weather radar, and surface observing system.
One of the major applications of satellite communication is in case of TV entertainment and news broadcast. For this application, communication satellites located in the geostationary region are used. These services are first introduced in India, so every citizen living in any part of country can be aware about latest trends in education and agricultural area. But nowadays it has grown in every sector, including entertainment, technology, lifestyle, art, history, etc.
Application of military satellite. A military satellite is an artificial satellite used for military purpose. The most common missions are intelligence gathering, navigation, and military communication. The first military satellites were photographic reconnaissance mission, and some attempts were made to develop satellite-based weapon, but this work was halted in 1967 following the reflection of intelligence treaties banning the deployment of.
A satellite navigation is a system that uses satellite to provide autonomous geospatial positioning. It allows small electronic receiver to determine their location to high precision using time signal transmitted along a line of sight by radio from satellite. Use of navigation satellite. Artificial satellite can provide the basic for all weather long-term navigation system to determine with accuracy geotic positioning, speed and direction of a surface vehicle or aircraft, north reference and vehicle reference. Currently, GPS has 33 satellite constellations, out of which 31 are in orbit and operational. It is maintained by US Air Force and is committed to maintain the availability of at least 24 operational GPS satellites. Till date, GPS has launched 72 satellites.